Hello friends, in this session we will be discussing about the JVM architecture. Like we have discussed about a bit of JVM architecture in the previous session. Now what we will be discussing is a major part of how the memory has been divided inside the JVM. So what happens is, first thing what we do is we write down the Java code. Java file will be available. We'll compile it and generate a .las file. Then we'll be loading this .las file. There are two ways which we have loaded the .las file. One is using the command called as Java. The other one is, this is a interview question. Now the other one is by using the new keyword. Whenever I say new of some class, right, first time the .las file will be loaded. Okay, so now when the .las file gets loaded, what happens actually, it gets loaded into some system called as class loader subsystem. I need space, so what I will do is I will write it down in a smaller box. Again, and this is the same size. Okay, this is called as class loader subsystem. This class loader subsystem is divided again into three things. Okay, one is called as loading, linking, and then it is also the other one is called as initialization. Okay, in loading we have three things, that is called as bootstrap, class loaders, extension class loaders, application class loaders. Okay, these are the three things what we have. Now what happens is, whenever I load the .las file, first thing the loading will occur, or first thing is the loading will happen. What is this bootstrap class loader means? The priority is same. First it will go to the bootstrap class loader, then the extension class loader, then the application class loader. The bootstrap class loader is nothing but the rt.jar, which is residing inside your JDK JRE lib, and this extension class loaders are nothing but it is residing inside the ext JRE ext. All the jar files will be available there. Application class loaders are nothing but the class jar files which is related to the application. You might be setting in the class path and all those things will be loaded. Okay, so now whenever I do this, whenever I load the .las file, first this loading will appear, then it moves to the linking part. Again, when it goes to the linking part, it is divided into three things. It is divided into verification, verify, it will verify. So see, if the loading is not successful, it will throw you an error saying that no class definition found error, or there is some other errors which I'll let you know in the coming sessions. Okay, so something called as, after this loading is not if the loading is not successful, then immediately the error will be thrown back to the client. If the loading is successful, this next stage is linking. In linking, it will go to verify. It is going to verify whether this class file is a junk code or it is a virus or something. So blindly you will be able to execute. That's why the people say Java is highly secure, because of this verification process. If it is not a bytecode, then immediately it is going to say, because you are giving me something wrong, I will not be able to proceed further. It is going to say. If it is all successful, then it goes to the preparation stage, prepare, and then it gets into After preparing, here in preparation it only gives the default values, like if at all I have a static member, it is going to assign a value for that, it is going to assign a default value for that static member, so some space would be allocated. Okay, then resolve. In the initialization phase, what happens, all the values will be assigned for the static variables, whatever the values we have given will be assigned. After that, it gets into the, after the class loader subsystem everything is successful, it gets into the memory area. This is very important for us as a developer, with the respect to the development point of view, this is very important for us. Okay, now it gets into the memory area. Memory area is again divided into 5 things. Okay, but majority, three major things we need to understand. One is called as the main memory. This will be called as the heap. This is called as stack, method area stack, you can say. And these two things, which is not really useful for as a with respect to developer point of view, PC registers, and then native method stack. Okay, now what happens is, in the main memory all the .class file information would be available, and static, for now just consider all the .class file, all the class information would be available, and all the static members information would be available inside the main memory. Whenever we create an object, the information of that object and the respective variables will be available inside the heap. There is a stack frame which would be created for every thread which is available. Okay, the respective local variables would be available, so that's why we say local variables are local for this particular method. Okay, and local variable array would be available, operand stack would be available. Okay, all this information will be available inside this stack. PC registers and native method stack is something which is related to the system. I'll be discussing this when we discuss more about other things in J2EE. I'll be discussing. So for now we can skip off. Okay, to give you a hint, right? The native method stacks were placed for, like, see, we need some information. Basically, this JVM is developed using the C program and C program, right? From the system, I need some code, some values. Okay, so this native method stack means the methods which are written in the native language. For that also there will be a stack. So that information would be available here. For every thread what we run, there is a entry inside this PC registry saying that what should be done next for this particular thread. So that information would be available. Mainly for as a developer point of view, we are interested in heap. And understand here, there is this thread, there is one thread. If I am running 10 threads in my JVM, so 10 stacks will be available, but heap memory will be only one, and main memory will also be only one. The information which is available in the heap is shared across multiple threads. So whenever we put the data inside the heap, we need to be very careful, because it is not thread safe. Here in the stack it's thread safe, because this whatever is available in this particular thread cannot be seen inside this particular thread. Okay, so this is one point which is very important. Heap is not thread safe. Heap and main memory is not thread safe. After this, what happens is, once everything inside the memory area is successful, then the class file is been passed into one thing called as execution engine. Execution engine. In execution engine, again it is divided into multiple things. Okay, one is interpreter, and one more is JIT, just-in-time compiler. Okay, interpreter means it takes the .class file, reads the .class file line by line, and then it interprets the code and then loads it into the JVM. Okay, but what is the role of just-in-time JIT compiler? Okay, if there is the repetitive code, like I have the same method execution to be I'm invoking the same method multiple times, should I always interpret the code every time and then can generate the machine code for that? No, right? So there the role of just-in-time compiler will come. See, first time when I load the .class file, right, this interpreter will read it every completely once. Okay, then when there is a repetitive code, there's something inside just-in-time compiler, there is something called as hotspot. Okay, that is called as profiler. Okay, it will read the .class file and figure out where all the repetitive code is there, and wherever I am invoking the same method each and a number of times, then comes the role of just-in-time compiler. It will, what it will do is basically it will figure out what is the .class file. If there is a repetitive code, it is not going to compile or generate the machine code each and every time. It is going to figure out if it is already there the machine code for this particular API, it is going to execute that, and then it is going to basically use the same earlier one itself. Okay, then after these things, next to the just-in-time compiler, there is something called as JNI, which is mainly responsible for see what happens is Java native interface, which is basically responsible for communicating with the native libraries and then execute the .class file and to get the output. This is just an overview of JVM architecture. If you do have any questions on this, you can please do leave a comment, and you can more about this, you can just go through the blog called as Open Lambda. There I have given the more information about Java architecture. I'll just give you an overview. In this video we have discussed about the basic overview. We will be discussing more about Java architecture and JVM architecture in the further coming sessions. Just go through this. If you do have any questions, please leave the comment. Here I have specified or have given a clear information about multiple things of JVM architecture. If you do have any questions, either you can leave me a note here, or else in the video itself in the YouTube. Okay, thank you guys, thank you for watching.